Hello and welcome to this Dr. Frost video on dividing algebraic fractions requiring prior factorisation, including a non-monic quadratic. Now I'm presuming you saw my previous video on multiplying algebraic fractions with non-monic quadratics, so we're going to use the same principle here. So we're trying to divide these algebraic fractions. Let's remind ourselves how we divide fractions. If, for example, I had 3/5 divided by 9/10, do you remember you keep, you change, and you flip, or reciprocate is the mathematical term. You keep the 3/5 as it is, you change your divide into a times, and you flip, you reciprocate the second fraction. So you flip it upside down, and then we can multiply the numerators. So 3 times 10 would be 30, 5 times 9, if we multiply the denominators, is 45, it'd be 30 over 45. But we could actually cancel before we multiply the numerators and denominators. Well, they don't have a common factor, so we can't simplify that fraction. We can't simplify that fraction, but we can divide the top and bottom of different fractions. We call that cross-cancelling. So the 3 and 9, they both have 3 in common. I divide that by 3 to get 1, divide the 9 by 3 to get 3. And similarly, if we cross-cancel top and bottom here, 10 and 5 both divide by 5, so 10 divided by 5 is 5, 5 divided by 5 is 1. And now that becomes much simpler to multiply, because we've got 1 times 5 is 5, we've got 1 times 3 is 3. So that is the final answer. We can do the same thing here, except we just need to factorise everything we can first in order to be able to divide by stuff like we had in this example. Now actually I'm going to do this first step here where I'm going to do keep, change, flip. So I'm going to keep this fraction as it is. So 2x squared plus 11x plus 12 over 3x to the 4 plus 12x cubed. We're going to factorise in a moment. We change the divide into a times. And then we flip the second fraction, we reciprocate the second fraction, so that's now upside down. Now we've done that, we just need to factorise everything we can to give ourselves stuff to divide by. So let's work on the easier bits first. Now here we've got a common factor. Always look for common factors first. Now 3 and 12, they both have 3 in common. Now x to the 4 and x to the 3, they both have x cubed in common. And then we put a single bracket. And then we think 3x cubed times what is 3x to the 4? Well, we need additional x. 3x cubed times x is 3x to the 4. And then 3x cubed times what is 12x squared? Well, 3 times 4 gives you the 12. And we've already got x cubed, we don't need to times by any additional x's there, so that is the final answer. This we can't factorise at all, there's nothing we can factorise out of it. And then the 4x squared minus 9, that is known as the difference of two squares. Remember how we do that? We put a plus in the middle of one bracket, minus in the middle of the other, and then we think, what's the square root of the first term? What's the square root of 4x squared? Well, it's 2x, not 4x, 2x, because 2x times by 2x is 4x squared. 2 times 2 is 4. And then what's the square root of 9? Well, that's 3, so we put 3 as the second item of each of those two brackets. Now, the thing I left till last was this quadratic here. It's known as a non-monic quadratic, as per the title, because the number in front of the x squared, the coefficient of x squared as we call it, is not 1. If it was 1, we'd call it a monic quadratic. And I'm going to do that over here. So the 2x squared plus 11x plus 12. Now I covered this and recapped it in the previous video, so I'm going to do it quite quickly here, but we can use a method called splitting the middle term. So what we do is we find two numbers that add to give the middle number, the number in front of the x, which is 11, and we find two numbers that times to give the first times the last number. So 2 times 12 is 24. What are those two numbers that add to give 11 times to give 24? Well, they're 8 and 3. So what you do is you split the middle term into the plus 8x and plus 3x using the 8 and 3. It doesn't matter if you do it the other way around, it will still work out. You could have the plus 3x plus 8x. And you can see that is the same as that, because 8x plus 3x is the same as 11x. We haven't changed expression. But we still need that 2x squared, and we still need that plus 12 at the end to keep this the same as that. It's no different, just in a different form. Then what we do is we underline the first half and the second half and factorise each of those halves. So we look, what's common to 2x squared and 8x? Well, it's 2x. And then what goes in the bracket? 2x times what is 2x squared? Well, it's x. And 2x times what is 8x? So it's plus 4. Do you remember we then leave a space and then we repeat the bracket? and then we think what goes into that space. What times x plus 4 is 3x plus 12? Well, it's plus 3, isn't it? Because 3 times x is 3x, 3 times 4 is 12. And then the final step is we see what's common here and here. So what's common here and here? Well, that whole of the bracket x plus 4. You have a second bracket, and you say, well, x plus 4 times what is this? Well, you can see it's 2x, because x plus 4 times 2x is 2x, brackets x plus 4. And x plus 4 times what is 3x plus 4? It's just 3. And the quick way of doing this last step is just to say, well, this repeated bracket, the x plus 4, is one of those two brackets, and anything outside the bracket, the 2x and the plus 3, forms the other bracket. But basically, the bottom line is we can now put that into here, our working over here, so we've got x plus 4, 2x plus 3. And now we can divide top and bottom by anything we find in common, either vertically or diagonally, top and bottom. So I can see top and bottom here, I can divide by the x plus 4, so let's just cross those out. I can also see that diagonally I've got a 2x plus 3 at the top here, 2x plus 3 at the bottom here, so we can cross cancel, divide, and then that gets rid of those. What else can we divide by? I can see a 9 here and a 3 here. I can divide those both by 3. So the 9 becomes 3, the 3 becomes 1. And then the x, the 4, and the x cubed, you can divide those both by x cubed. So the x to 4 divided by x cubed, you're just left with single x, because x times x cubed is x to the 4. And the x cubed divided by x cubed is just 1, so we just put a 1 there. And that makes it much easier to multiply now. We've got nothing left here. If you've got nothing left, you can just put a 1 there. And then we've got 1 times, we just got the 3 and the x. Well, 1 times 3x is just 3x. And then what we've got at the bottom, we've only got 1 here, the 1 here. Nothing's left here except for the 1. And we've just got the 2x minus 3. So 1 times 2x minus 3 is just 2x minus 3. And that is the final answer.